how far away are these objects? And we'll just start from the top left over here. What are we looking at over here? You know, how far away is it? And then maybe talk to us a little bit about your process in creating this image.
Right, so this is a galaxy. This is called M106. The interesting thing about this galaxy is you can see this sort of weird wavy shape in the middle of it. If you're looking at this in optical light, you don't see that at all. There's no indication of this strange shape, unless you're looking at a very specific wavelength of light. And what that actually is, it's called the anomalous arms of M106. And in this image, we're seeing X-rays in blue and then radio wavelength in purple. And then to balance all that out, we have the optical data from the Hubble Space Telescope, and that's in sort of a kind of a gold color, and then infrared data from the Spitzer Space Telescope in red.
You know, what informs you to actually make, you know, this white? I mean, I assume like that's the hottest part, correct?
Right. So this is actually a really good example because this image started with a press release image from the Hubble Space Telescope, which was a very colorful image. It was a full 3-color image, what we call it, red, green, and blue. Our group is very concerned with color confusion for the general public. We want to be able to say that things that you see in this image that are colored blue are X-rays. And so if you have an image that has blue from optical and blue from X-rays, then there's some confusion as to what's what in the image. And so I made a creative decision to take the full color image from Hubble and decompose it into its constituent colors and then recombine it in a way that made room, so to speak, for other colors to show through. So the Hubble data is actually sort of reduced down to a lesser palette of colors, and that frees up color for other wavelengths. And so the red you can see comes from the Spitzer there, that's infrared, and you wouldn't really be able to see that as clearly if we kept all 3 colors from the original image. And then of course you can see now that anything that's blue in this image is coming from the X-rays. And the reason that the center becomes white is because that's where all of these colors sort of come together. And wherever you have that, you have white.
How accurate would your image be to how this galaxy actually looks?
Well, what I can say is that we're not making anything up. You know, this is real data. This is what the telescope sees. And like I said before, a telescope can see things that our eyes can't see. Like for example, the Chandra mirrors can focus X-rays to such precision that it's equivalent to being able to read the letters of a stop sign from 12 miles away. So we can focus in a way that our eyes can't with these telescopes. But if we could get close enough to it to be able to see it like this, of course these colors wouldn't be there because this is stuff beyond the visible wavelengths.
Sure.
But the colors that our eyes could see, it really would just kind of look like a faint smudge. If you look online, do Google searches for images of the Milky Way, people have taken some really incredible ones, and they look as cool as some of these images because we live in the middle of a galaxy and we can look up and see that, but our eyes just can't resolve that kind of detail or color.